This video is going to help you with your lab number 8 on extrasolar planets, making your plot of the extrasolar planet 51 Peg B. So this is part B of your lab. So I'm going to go ahead to part B. Here we are, part B. So this is using the Wobble method or the radial velocity method. So the part that I'm helping you with here is plotting your data. So the data table that you're given in the lab is the actual data from Marcy and Butler. Okay, this is the original data collected in October 1995 from the Lick Observatory in California. So what you see on your data table here is you're given the day, the radial velocity as v, measured in meters per second. Okay, so you can notice that the table goes day, and the day increases in each spot here. Okay, so those are your two things that you're plotting. So you're going to make a plot. So I've given you some graph paper on the Canvas site, or you can plot this in an online program like Excel. It's up to you, but I kind of prefer the hand version. I think it's a little bit easier for making your Sine plot. But here's the directions for graphing your plot. So this is an example plot. So your data is going to look something like this, okay? So notice that the scale, okay, so we have our y-axis, which is your velocity, so that's the radial velocity. That's in meters per second. And your x-axis is going to be the time. So notice that the 0 on the y-axis is in the middle of the graph, and it's the data going positive or negative, okay, because that's the radial velocity. Okay, the star is wobbling because the planet is orbiting around it. So the star is either moving towards Earth or away from Earth. So the plus minus is the star wobbling towards or away. Okay, so that's what we're plotting here. We're plotting the towards and away over time of that star. So notice in the directions it tells you that we're going to do x-axis as time and y-axis as radial velocity. That your x-axis is going to start from 0 going to 14 days, and your y-axis is from minus 70 to positive 70 meters per second. Okay, whereas this example is going to 100. Okay, so let's go ahead and start this together. So I have my pencil and my graph paper. And so we're going to make our x-axis time. So time, and that's going to be in days, right? It's always important to label your units. And I'm just going to put an arrow indicating that time's increasing towards the right. And then our y-axis over here is going to be radial velocity. And that was measured in meters per second, okay? So I said in the directions that the x-axis, time with an E, the x-axis needs to start at 0 and go to 14 days. So of course, depending on your graph paper, you want to determine how to lay that out. So I might say, okay, so let's look at each box. How many increments are within each box? So 1, 2, 3, 4. So 4 subdivisions within one dark line. So if I made each dark line 1 day, let's see how many subdivisions. That would mean this would be like 0.2, 0.3, 0.4. That doesn't work, so 0.2, 0.4, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these is 0.2, and that works out pretty well. So 0. So I'm going to mark each of these bold lines as a day. 2, 3, 4, all the way up to 14. Remember, within each of these is 0.2 of a day, okay? So now for our y-axis, the directions tell us that we'll need to go minus 70 to positive 70 and 0 somewhere in the middle. So I'm going to make each major line here be 10. So 10, 20, 10, 20, 30, 40, 50, 60, 70. Let's see if that works. 10, 20, 30, 40, 50, 60, 70. Okay, that will fit on our papers. So for our y-axis scale, let's start with minus 70 at the bottom. 60, 50, 40, 30, 20, 10. And then we'll put 0 here. Okay, so then this will be positive 10, 20, 30, 40, 50, 60, 70. Okay? All right, so there's our scales. Okay, so let's look at our data and just make sure that makes sense. So let's look at We know our days, okay, going from 0 and nothing higher than 14, so that works out fine. And let's make sure there's nothing above or below positive 70 or below minus 70. So I'm just going to look at our radial velocity. There's a 66. Okay, so I see nothing above 70, so that's good, and nothing below 70. So I know my scale can work out pretty well. Okay, so now I have my graph all ready to go. Okay, my axes. So I have time on the x-axis going days from 0 to 14, and radial velocity on the y-axis, 0 in the middle, negative 70 at the bottom, positive 70 at top. All right, so now I'm just going to go ahead and plot my data. So I'm going to grab my data table, and just like you're going to do at home, I'm going to start plotting. So let's see, day 0.6. So remember, each of these was 0.2. So 0.2, 3, 4, 5, 6. So right in there, 0.6 is at minus, on my data table here, 0.6 is at minus 20.2. So remember, these were each 0.2. So 1, 2, 3, 4, 5, 6. With this line here. And it's minus 20.2. Well, I don't quite have that fidelity with the 0.2 in my scale here, right? Because if this is 20 and this is 30, that makes each of these 2. So this is 22, 24, 26, 28, and then 30. So it's almost pretty much on the 20 line. So I'll just go ahead and put that almost pretty much right on the 20, minus 20 line, right? Because I can't quite get to the fidelity of 0.2, and that's okay. Okay, so then we'll continue plotting. So 0.7 is going to be right next to the 0.6, in between 0.8, so in between that line there. And it's minus 8.1. So 8 would be just below the 10. So I'll put my next dot right there. So in between that there, and then we'll continue to plot the data. So now that we've plotted all of our data points, we want to fit a sine curve. So you know that the sine curve is going to go up and down in a sinusoidal fashion. So my suggestion is to pick the lowest and the highest points, the most negative point on your plot and then the highest, most positive point. So if we look at our plot, it looks like this point here is our most negative point. So we can actually look at what point that was. That was 12.3, 4, 5, 6, 12.7. So that was this third to last data point. That was this one right here. Right? And so our value was a minus 48.7. Right? So minus 48.7. So that's our lowest value. Okay, so we're going to make that the lowest point of our sine curve. So I'm just going to make a little mark on either side to remind myself this is the lowest value we're going to use, this line. Now let's look at our highest value. Looks like it's this value here. So that was at like 1.6, 1.7. So again, if I look at my data sheet, that 1.7 was here, the 66.8. Okay, so if we make that our highest and our lowest point of our sine curve, you're just going to try to fit a sine curve best you can. So we want to, you can kind of already see the roundness. So you can see that there's probably like around here, right, will be a trough. And here will be your peak. So I'm going to start off at my lowest point here. So I can see that the end of the curve is probably coming in somewhere like this. This point maybe makes a little bit weird, but you can see that maybe you sketch here. So I am literally just going to try to sketch it best I can. And that's what I suggest you do. And you can kind of make adjustments as you go along. So I'll use this point down here, the negative 48, as my lowest point. So that'll be my lowest point of the curve there. And I want to bring the rest of my curves to that negative 48. So here I can see the curve forming here, but I want to bring it down to negative 48. So again, you can already see, pencil is always helpful. So I'm going to bring it down to negative 48 and then up through as many of these data points as I can. I'll do the same thing over here. Here I can see it's coming down. I'll hit my negative 48 point and then come up through these data points. Okay, so there's my troughs. Okay, and obviously this one here looks a little pointy. I mean, you're just doing the best you can here. Okay, I didn't even know if I made that any better. And so then you want to, your sine curve is going to come up through these data points, and we decided our highest point was this one of the 66.8. Okay, so if I kind of bring that across, I'm not going to want to go much higher than this on any of my curves. So I'll bring this up and I'll round off the top, coming back to these points, and I want to connect to these bottom points. So I'll come down best I can. And then again over here, I want to round off so these points will come up, hit the highest point, and then go through as many of your data points as possible. All right, starting to look a little bit like a sine curve. So there's my sine curve, okay, my fit to my data. So this is the data points. This is the star's wobble from the planet 51 peg going around it. Okay, so 51, the star. 51 peg B is the planet, 51 peg is the star. It's moving back and forth because of that gravitational pull from the planet. So in your lab, you want to know a few things, okay? So you want to know the period. So we calculate the period of a sine curve. A couple different ways you can do this. One is by looking at the time in days from peak to peak or from trough to trough. Okay, so my suggestion to you is to take an average to get the period, right? Because this is my best estimate of a sine curve. So I'm going to start by going from peak to peak. So here I'll go from peak to peak here. So I'm looking at this distance, peak to peak. Okay, so I have a ruler here. So I'm going from peak to peak. So this peak here, we knew it was that exact data point we were at. That was at 1.7. 1.7 days. And then this peak, okay, just bring my ruler down, sitting about there. So that's 6.2, 6.4, about 6.4. Now, I said about, right? Okay, so there's period right there, okay? So to calculate the period, you're taking the difference from the time from peak to peak. So I have my calculator here. So the difference would be 6.4 days from that peak minus 1.7 days. Okay, so from peak to peak there, you can see on my calculator, it's just about 4.7. So this is about 4.7 days. Okay, so there's one period. But remember, we just kind of estimated this. So let's do another one. So let's go from peak to peak here. Okay, so we know we're at 6.4 days there. And there's another peak. So let's measure what that peak is at. I'm just bringing my ruler to help me guide. Okay, so that is about 10.2, 10.3 days. Okay, so I'm looking at this difference here. So now I'll do the same thing. So 10.3 minus 6.4. Okay, that's about 3.9. All right, so you can also measure the period of a sine curve by looking at the difference from trough to trough. So peak to peak we did. So we have some troughs here as well. So let's go from trough to trough. So from this point here to this point here. So I'm taking the lowest point, right? Okay, so I'm looking on the edge here. So this point here hits about 4.1 days. And this point here is hitting about 8.2, 3, 4, about 8.5. Okay, so you want to know the difference, right? How far between trough to trough. So 8.5 minus 4.1. That was about 4.4. Okay, so at least get 3 periods to take an average. We'll do one more just to, get as best we can. So I'll go for the next trough, so from trough to trough. So I'll go from here to here. So I'm going to grab this point. Let's see where that hits. That's about 12.1, 2, 3, 4, 5, 6, 7, 12.7. Okay, so I'm going to do from trough to trough there. So 12.7 minus 8.5. So from here to here is about 4.2 days. Okay, so I've calculated now 4 periods. Okay, so period is just the time it takes for the sine wave to be at a peak and come back to peak again, or to go from trough and go to trough again. So I have 4 different values. I have 4.7, 3.9, 4.4, and 4.2. So let's take an average of these periods. An average just means add them together and divide by how many you have. So I have 4 periods. So I'll add these together and divide by 4. So we have 4.7 plus 3.9 plus 4.4 plus 4.2. Okay, take those and divide them by 4 different periods. Oh, and look at that, 4. So our average period, okay, I'll write this over here, period, we're representing as capital P for this lab. Period is, I got 4.0 days. Okay, so yours might be a little bit different, of course, right? Depending on where you fit your sine curve, and that's okay. So go ahead and take an average to get your period. Now, we're also going to want to know the amplitude of the sine wave, okay? So to get the amplitude, that's on part 6 here, average amplitude. You're going to look at the minimum and the maximum. So we already determined our minimum and maximum, right, from where we did our sine curve. So we use this maximum point here, and we use this minimum point over there. And I circled those on my data sheet, which that might have helped you as well. Yours might be a little bit different. It's okay. So 66.8 and minus 48.7. So you'll divide, so you'll add those together. You'll subtract them, okay? 66.8 minus negative 48.7, okay? And divide those by 2, okay? To get the amplitude. Okay, and from the amplitude and the period, you'll be able to determine the mass of your planet in terms of Jupiter masses. All right, I hope that helped you out a little bit on plotting for this lab.